Welcome to International Biorenewables Law and Policy. This presentation is part one of a two-part series on the controversy surrounding indirect land use change and the food versus fuel debate with ethanol production. We will start this module by discussing some of the fundamentals behind indirect land use change, the discussion surrounding the topic, and some of the potential inaccuracies of the impact of biofuel production on land use. To become familiar with the concept behind indirect land use change, we could use this diagram here as an illustration of what it actually entails. The idea behind indirect land use change is that if you take land in a particular part of the world that is being used for one particular application, for example, growing soybeans on the left here, and you convert that land to a different use, for example, convert it into pasture land that you use to raise cattle, the food that was originally being grown in that area will have to be made up somewhere else in the world. The idea is that the world consumes a certain amount of food, and that any net change in land use in one region has to be compensated with a change in land use somewhere else. The change from soybeans to pasture land is what's known as direct land use change, and it has direct impacts on the environmental profile of the land being used. What is more difficult to quantify is what is known as indirect land use change. Now, assuming that there's enough pasture land or excess pasture land around the world, a responsible change would be that another nation or another region will start grazing pasture or clear land somewhere else to grow soybeans in a responsible manner. However, what often happens is that when you replace land, fertile land used for production of food, the notion behind indirect land use change is that some countries would take forested land and clear it in an irresponsible manner, leading to significant emissions of carbon from the cleared trees. And this would lead to negative environmental impacts on a global scale. The theory behind this is also supported by the idea that by producing biofuels and taking land away from food production, not only are we requiring that a less productive part of the world produce that food, but we're also increasing the cost of food by increasing competition for land. This question or this theory is difficult to test because a lot of these impacts are global in nature, are dynamic, take time to be observed, and involves a lot of different actors. One attempt at studying this impact was done by Searchinger et al. In 2008, where they calculated the potential impact of increasing grain ethanol production in the United States to global emissions around the world. They came to the conclusion that grain ethanol actually causes more greenhouse gas emissions than gasoline because of the deforestation of old growth forest around the world due to indirect land use change. However, there's been a lot of debate surrounding this article, which appeared in Science, a notable journal. After the completion of the paper, but before it was finally published, Congress had to change some of its rules on the Environmental Act in 2007 and the Energy Independence and Security Act of 2007, requiring that indirect land use change calculations should be included in the calculation of the emissions of biofuels. This has certainly resulted in a drastic change in our estimate of biofuel production emissions, but more importantly, it started a stampede of researchers developing the tools to improve our understanding of how indirect land use change effects take place and quantifying the potential impacts of indirect land use change. Clearly, newspapers and the media ran with this debate, and it's very easy to find stunning images of, for example, slash and burn agriculture on the left here in Brazil. In the right, you have a beautiful image, but clearly you have a rainforest that has been cleared to grow soybean fields. So this is a phenomena that is clearly happening around the world. However, despite the impact of these images, the question still remains, are biofuels causing deforestation around the world? If you read Search Engine's paper, you will see again that when you include land use change and indirect land use change, most biofuels produce more emissions than gasoline. Gasoline here with 91 grams of CO2 per megajoule, and you have all these different forms of biofuel production having greater emissions, with the exception of biomass ethanol. But even in the case of advanced cellulosic ethanol, you see that including land use change leads to higher emissions than gasoline. Subsequent papers, actually by some of the collaborators in Search Engine's paper, many of these collaborators are faculty here at Iowa State University, have found that small changes in the assumptions of the study resulted in dramatically smaller indirect land use effects. And so in 2011, several years after the science paper, Dumortier and other faculty that were involved in the first study applied a sensitivity analysis. They varied key assumptions in the analysis, and they found that even though the worst case scenario was possible, the chances of it were very unlikely. And the emissions estimated from Search Engine's paper probably were overestimating the emissions of biofuels. Similarly, other national labs and scientists around the world came to the defense of biofuels' impact in indirect land use change. But clearly, the science behind this is still in an early stage. The causes for deforestation are incredibly complex, and it's simplistic to blame it on a single factor, as said by Oak Ridge National Laboratory. One way to look at this is to try to see if there are any statistical correlations between ethanol production and deforestation rates. The data that we're going to show here doesn't prove or disprove the hypothesis that biofuels cause or do not cause deforestation, but it's just for argumentative case, to make an argument that perhaps we need to look a little bit more carefully at the growing evidence around biofuels and deforestation. What we see in this first graph is that as ethanol production has grown over the past 10, 15, 20 years, it appears that with higher ethanol production capacity, deforestation rates have actually appeared to be decreasing. There's a very low significance level here, and so we can't really draw a conclusion from this data other than there appears to be a trend in which deforestation decreases with ethanol production. How about soybean prices? We've suggested that competition for land increases soybean prices. Well, are soybean prices leading to deforestation? Again, we see that with higher soybean prices, deforestation appears to have a slight decrease. Similarly, an increase in the price of beef and meat appears to have a negative trend relative to the deforestation rate. Obviously, we're not saying that increasing the price of beef is going to decrease deforestation, but certainly the opposite doesn't appear to be the case. One particular region of the world that has been the center of this debate is the Brazilian deforestation Brazilian forest. What we see in this graph is that U.S. ethanol production, in particular, which has taken off dramatically since the late 90s, that phenomenon occurred during a period in time in which deforestation in Brazil decreased significantly as well. And so just by looking at this graph, it would be hard to conclude that U.S. ethanol production is increasing deforestation rates in Brazil, when actually it appears that the opposite has been happening. So to conclude from this discussion, despite the study by Searchinger 2008, which brought a lot of attention to the concept of indirect land use change, even Searchinger admitted that to gain reasonable confidence in the greenhouse gas reductions of biofuel production would require a careful approach to estimating indirect effects. And that more than likely at this point, there are no single models that can capture the impacts of indirect land use change in an accurate manner. The faculty at Iowa State that collaborated with Searchinger went a step further and said that in their model in particular, it is very difficult to narrow the range of reasonable parameter values so that you can get a result that would allow you to come up with a robust policy conclusion on indirect land use change. These comments underscore the difficulty in understanding the complex chain of causation that goes between changing land to produce biofuel in one region and the potential greenhouse gas emissions caused by clearing land in other parts of the world. This is a topic that I think scientists are going to debate for the near to long-term future of biofuel research, and one that will be difficult to address given the complexity and scope of the problem. However, as we move on to advanced types of biofuels, it is important to always keep in mind the potential advantages and disadvantages of using different feedstocks, conversion technologies, and application markets.